and welcome to episode 189 of The Joy of Coding. My name's Mike Conley. Gonna be looking at some Firefox stuff today. I'm so glad you're here. Thanks for being with me here today, this Wednesday, 1 p.m., September 18th, 2019. What are we doing? Let's get into it. Let's check it out. Hold on. Let me just switch my screens here. I'm a little disorganized. There we go. All right. Let's pull up today's agenda. Today is September 18th, 2019, episode 189. And remember, no plan survives breakfast. I'm starting a little bit late today because there's a little bit of a kerfuffle with the repeater and the encoder and all that business. But hey, here we are, 13 minutes past the hour, and we made it. But that's just another example of things not necessarily going according to plan. None of the stream is scripted or pre-planned, so who knows how it'll go. So if things go wrong, that's okay. I just want you to know that I'm recording live and off the cuff, and who knows what'll happen. We're going to get ourselves into all sorts of trouble. The other thing I wanted to let you know is that there is an agenda. That's what we're looking at right now. This agenda that we're looking at is something that you have access to. Let me show you. There are links here, and they're all super handy for you to click on. And if you're watching this on YouTube, check the video description for a link to the agenda. If you're watching this on Air Mozilla, it'll be in the handout section over on this side of me, right over there. And if you're watching this on Twitch, then I'm about to drop it into the Twitch chat right now. Boop. There we go. It's in the Twitch chat. That is the agenda. All right, so there's also an episode guide. I want to plug the episode guide. The episode guide is a completely viewer-driven... Oh, sorry, went over to the wrong window. Pardon me. Let me drag that over here. The Joy of Coding episode guide is completely viewer-driven. Just, awesome viewers just like you put together these episode guides. And we've got all the way up to the last episode, 188, posted. Very, very handy if you want to know what got covered in previous episodes. So, for example, in last episode, 188, it looks like we did some code review on some Flash stuff, and we landed this other patch over here, and we added a big comment over here for the subframe crashing regression test, which an update is now on by default. We were able to get that landed. And we also learned that debug artifact builds will not give you the source in GDB. Lots of interesting stuff last episode. And here we are again in episode 189. So if you yourself have things that you want to add to the episode guide, because it's for you, the episode guide isn't just, it's not for me, it's for you, the viewers. So if there's stuff that you want to add, for example, your own notes, addenda, corrections, if you want to expand on some things, send a pull request to the repository. I'm very open to merging in all sorts of things into the episode guide. So if it's useful to you, it might be useful to other people. If you're not sure what I mean by a pull request or a repository, there are links here in the agenda on, figuring all that out and what that means. There's a contributing guide, how to contribute to the Joy of Coding episode guide here. It kind of walks you through it. If you're not familiar with Git, we're using GitHub to host the episode guide. So you can get, there's a great book called the Git book that you can read on how to use Git. And here's just some guides on how you might be able to contribute. So just putting that out there, if that's something that you want to contribute to, I say go for it. The next thing I want to mention is what we're doing today. First of all, I want to give a quick update on communications. So at Mozilla, we've been trying to phase out or slowly move away from IRC as our primary sort of asynchronous and synchronous communications platform. IRC has served us very well for decades now, but there are a lot of problems with it, and we're looking to replace it with something else. And if you're curious to know about this project, you could read more up on my colleague's website. There is a blog post here that you should read. So like some background. I'm putting that in the agenda. So if you want to know about it, I've saved the agenda. So if you refresh the agenda, you'll get the most recent link there to the background blog post. But I think he posted something even more recently. Where is it? Forward motion. Yeah, we mentioned that Mattermost, Matrix, Rocket Chat, and Slack are the 4 candidates for the replacement. And we've started to stand up the initial test servers. Let me see if I can point you trial servers and feedback. So you can try these out. These servers now are available for people to hack around with. We've got like a matrix instance that I've signed into to test out. I've tried the Mattermost and the Rocket one. So I'm gonna, if you're curious to give feedback and test those out, test servers. These test servers are only going to be around for like a month or so, and then all of them are just going to get torn down and blown apart. This is really just an opportunity to get feedback. So feel free to join us there. There's a Riot instant messaging client that I'm now opening up. I'll tell you what I'll do is, in case anyone wants to test it out with me, I will join the I will create a Joy of Coding channel on the Mozilla Matrix server here. So let me just create a room real quick. Add a room, create a room. The Joy of Coding, or maybe I'll call it live hacking. I'll create a live hacking room. There. And let me change the visibility. Security and privacy. And who can read history? Anyone. Advanced. Room ID. Room topic. Room address. Main address. It's just live hacking. So there we go. I'm now in the live hacking room. So I don't know if anyone wants to join me there, but if you go to the Riot, the Mozilla Test Riot Matrix instance, I am now in the live hacking room if you want to join me there. Ba-bwam! And we can try it out together. And now I'm going to get all sorts of messages from the random channel here. I'm going to turn down the alerts from it. Awesome. Okay, let's move on to actually doing some work. So that's an update about synchronicity. What was I hoping to do today? I was hoping to do a performance analysis. This is going to take a little while, and I don't know how far we're going to get today, but I was asked to work with a couple of people who've been doing a port of our localization framework from, we've been using, I should say rather abusing .dtd entities to do translation in Firefox Desktop for a long time. Like, let me show you how we currently do localization. If I go to, where's a good example? Let's go to browser.xhtml. So this is the main markup for a browser window. One of the things that we do near the top, let me pump up the font here, is that we will, did they already do it? Have we replaced them all? May have replaced them all. All right, let me find a different case where we bring in .dtd files in like an XHTML document. Okay, about net error. So about net error is the page that if you were like to see a network error, like net error, like a problem loading page, like one of these, or like a 404 error, it'd be this page. And this is how we do localization on it. Oh, by the way, if you're wondering why my computer's a little sluggish, I am doing a build in the background. I'm hoping that that will be done by the time we actually have to like run some stuff. We shall see. So the way that we would bring in strings, localization strings, is we would use these like this old school DTD stuff. DTD, what does DTD stand for? What does DTD stand for in XML? This is like part of the whole XML thing. DTD is document type definition. And we abuse those a little bit. We load them in from a URI, and these files, if you look at them, if you look at what they look like on the file system. They're really just key value pairs. So, I mean, there's a lot of decoration about how we like describe the keys and values, but ultimately this is a key and this is a value. And the keys are these like unique things, unique keys, and the values are strings. And the strings are the translations that go into the document themselves. And so like if you look at the markup, there's going to be a couple places where we have these special basically this is how we bring in translations, is we'll say like at, then the key, and then the semicolon, and then our document parser at parse time will find the DTD file and insert the strings at document parse time. And there are a lot of problems with that. I mean, it served us well for many, many years, but there are a lot of problems, not just from like the developer standpoint, but these DTD files and .properties files are a problem for our translators and our localization community as well. And if you're curious about like what the problems are, there is architecture. I think there is a document, proposals, document architecture, experiments, Rust on Android. There was like something in here that I think was problems with Fluent in prefs. That was one. Fluent describes the lightweight design review. Fluent architecture to migrate from DTD and properties files to FTL files processed by Fluent. That was the other thing. So we can only use DTD files inside like markup, like XML or HTML, things like that. And for JavaScript, things that we're doing dynamically, maybe we would use these .properties files, and then we have to use this JavaScript API to go get the strings. And the .properties files are very similar key value. Like, let me show you an example of a .properties file. Places. So this would be one of the keys, and this would be one of the values. Very similar to the entity things. But the fact that we had two different ways of doing this was, I think, painful. And Fluent, which is what we are migrating to, allows us to have like a single file format that we migrate to. And there are a whole bunch of other really excellent things about Fluent that that we're looking forward to having baked into our localization framework. So the idea is to migrate everything away from .properties and .dtd files to Fluent. And there's a website, arewefluentyet.com, that tracks our progress porting things away from DTDs to Fluent. So this region down here, this sort of fuchsia region, is the number of DTD values that we have in the tree, and that's been going down and to the right. This bluish area in the middle, that's the .properties files. There are more of those than DTD files, certainly. Or rather, DTD strings and property strings. And, oh no, what just happened? I just realized, for some reason, I saw like the Mozilla thing on Twitch. I don't know what happened there. So if I dropped out for a second and there was loud music, I don't know what happened. The repeater. Maybe I was dropping frames. No, OBS says I was not dropping frames. Who knows? Who knows what's going on there? Akra says it was a good scare. You got a good 10 seconds of just like music, music. Well, hopefully it doesn't happen again. That was very unusual. I don't think that's happened before. So hopefully it doesn't happen again. All right, so this middle region is about the number of properties strings, or properties, localization strings, and that's going down to the right. And this region up top is the number of Fluent strings, and that's starting to overtake. Like, we've made some inroads, and now we had these 2 modes, and now we have 3 modes of doing strings, or 3 mechanisms for doing strings. You know, it's that classic XKCD comic where they're like, oh, we have 12 competing standards. We need to combine them all into like one single standard. And now you have 13 competing standards. SmurfD says, wasn't able to join the live hacking thing and the Mozilla test riot thingy. Maybe I didn't do it right. I will quickly check the settings. One moment. Settings. Security. Anyone who knows the room link. I want to make sure that this room is public. How can I make this room public? Set the roles. Notification advanced. I think this room's public. Like, should be just live hacking. Did I do it wrong? Maybe I did it wrong. I'm sorry. I'll look into this later. Shoot. All right. Anyways, so I've given you background. We're moving away from properties and DTD files to Fluent. Great. And then this performance review request came in. So the Fluent team is hoping to migrate a whole lot of the browser front end to using Fluent. That's great news. It's possible that they've already done a bunch. Like, we were just looking at excuse me. browser.xhtml, and we saw that there aren't any DTD files being brought in. So it's possible that they've completely moved all of browser.xhtml over to Fluent already. Let's take a quick peek. I know one of the things that they brought over recently. Oh, no, hold on a second. They've still got, like, main window title here using, like, the old DTD mode. Oh, browser doc type. All DTD information is stored in a separate file so they can be shared. Okay, so we're still bringing in DTDs here. And let's see what DTDs we're bringing in. All of these files. Okay. Okay. And the idea is we want to be able to swap all of those out with Fluent. And when the way that you can recognize Fluent being used is how they how they manifest inside the markup. Specifically, you'll see things like lazy L10n ID or data L10n ID, data L10n sync. Like, data L10n is kind of like the namespace for the attributes, and you use those to decorate the DOM nodes that you want to inject your translated strings into. And there's like a pretty sophisticated way of expressing, you know, if you want to have the inner text being set or if you want a different attribute being set with a particular string, and that's all stuff that Fluent supports. It's really nice. But if the idea is to move more and more of this away from the old DTDs to Fluent strings, what is the performance impact? What is, like, will that impact the time it takes to open and draw windows? Will that impact painting the windows? Will that impact just browser startup in general? And that's what we've been asked to investigate. My team has been asked to investigate that. So I've started to I've just barely scratched the surface of this thing, and I'm hoping we can dig in a little bit in this episode and try and get some sense of it. Okra says, too bad all of these clients are web-based and nothing is lightweight. Okris, I do believe you are allowed to use WeChat and communicate with Matrix, or like the Mozilla Matrix thing. There are also like non-web clients to communicate with Matrix. I actually wouldn't be surprised if there are a number of non-web ways of communicating, not just with Matrix, but with the other ones as well. Rocket and, what was the other one? Rocket, Mattermost, and Slack. Yeah, I suspect that there are a couple there that are not web-based. Okay, so here's the scope of the analysis. We're going to look at the current impact of Fluent on the startup path and any foreseen impact of Fluent on the startup path as more strings are converted from DTD and properties files. We'll be primarily focused on impact on startup time, but we'll also be looking at memory usage, because that's another thing that they were concerned about. Like, are the structures that are holding all of the localization information consuming more memory, or like prohibitively more memory than the old mechanism? That's the question. So I started taking some notes here. For the first thing that sort of came to mind, or someone mentioned to me, and I thought it was a good thing to think about, is that, I mean, not all locales are the same. English is the one that I use, but there are certainly other locales that will use fewer characters, but they might use Unicode characters. You know, like traditional Chinese or Farsi, like the Hebrew, they'll use these Unicode characters, and those might be stored in like they might take more bytes to represent. So that's one thing to think about. There are also just languages where the strings will just inevitably be longer. I'm looking at you, German. German, generally, the strings are way, way longer. So I wonder what the impact will be. We can't just test English. We're going to have to test a number of these things and see if we can get a sense of the different characteristics. So do longer strings matter? Does it make things worse? Does it make things better? Do different character, like the number of bytes to represent a character, if it's UTF-8 or UTF-16, I think we always use UTF-16 to represent these strings, but like if it's the upper band of the Unicode characters, does that impact things? I doubt it would, but you never know. So which locales should be tested? So things that come off the top of my head, I mean, English is our largest locale, so that definitely needs to be tested. So like American English, ENUS, but also German, probably Polish. It'd be good to look at traditional Chinese and maybe Persian. Traditional Chinese. Persian, like as just sort of a broad spectrum here. I might need to talk to Gandalf or Flawed from the L10n team to get more suggestions. But those are the ones off the top of my head to test. Okra says Chinese, Japanese, and Korean should be the slowest, so probably worth testing. Yeah, perhaps. Korean, Japanese. Those are the ones that I've like the picked a sort of the like iconographs, whatever you call those, where a word is just like a single character, or like words are it's not phonemes with letters like in, for example, English or French or German, but you have these, they're not exactly pictograms. What are they? What's the word? I don't remember, but it's like one character can represent an entire word. Okay. So that's the first idea, or the first question. And the next thing I want to know is how all of this works. What is the life cycle of the Fluent mechanism during startup? And that's something I'm hoping we can try and answer during this episode. So let's take a look at how Fluent works during the startup path. I think the first thing that's important is to look at the there was like a design document that we saw recently here. And I think we can start with this as a way of giving us hints on how this stuff works. So what we're looking at is the browser architecture team migrated about preferences, that's the sort of options UI, to using Fluent instead of .td and .properties files. They migrated all of about preferences to using Fluent. And that was kind of like a testing ground. And I wanted to see if maybe there's something in here about how it works. Schedule, migration, string changes. No, there's nothing in here about how it works. There was, so the actual performance review request. Let's take a look at that, because there were some interesting documents that were logograms. Thank you, Smurfd. Logograms. This is a public document. I don't know why it says like these. Gandalf was supposed to pick one, but he didn't. But this is a public document. Okay, let's see here. Design documents, UI spec, data flow diagrams, explainers. That's kind of what we want here. We want data flow diagrams. What are these? Fluent new localization infrastructure, Fluent in Gecko, new localization infrastructure, war on yellow screen of death, localization registry requirements, localization challenges. Let's start with this one. So they lay out like, here's our current system and here's where it falls short. And then they start talking about the new. This is exactly what I wanted. This is a diagram. Okay. New infrastructure. The Mozilla localization team has been working on a new modern localization system that aims to both replace the current Gecko L10n infrastructure and become a foundation for the future web L10n APIs. Your system grew of experiences working with Firefox localization over years and our involvement in JavaScript internationalization processes. So it consists of two major components. The L10n Registry. All localization resource requests go through a component called Chrome Registry. We've been asked by its maintainer to move localization away from it as it doesn't serve us well and ultimately would like to get rid of it altogether. Yeah, that makes sense. Current registry is responsible for half of the shortcomings listed above. It has not been designed for localization. The Chrome Registry handles localization almost as a side effect with the risk of race conditions and... let me close Slack. I don't want notifications right now. Turn off notifications. Hold up. Okay, nothing. No notifications. Okay. All right. Currently, registry is responsible for half the shortcomings. In contrast, the L10n registry has been designed exclusively for localization resources. Operates on best practices of language selection and fallback. Right. So I think one of the key things that the localization team is attempting to fix is something that you nightly users may have experienced before called the yellow screen of death. And that's what happens whenever you try to open either the main browser window or any browser UI. And what you end up seeing is a rectangle that's yellow. It's got like red text and it says like this really cryptic, really sort of cryptic error message. Let me see if there's like a yellow screen of death document here. Maybe they'll show you an image of it. Where can I find the yellow screen of death? Firefox yellow screen of death. Because maybe you've seen this thing before. Yeah, this thing. XML Parsing Error. This usually happens whenever there's like a missing localization entity. And so the old DTD stuff just absolutely, if you'll pardon the expression, craps the bed whenever it's missing a string. Whereas Fluent, having this in mind, like the yellow screen of death is basically like, oh snap, we didn't find a string, explode. With Fluent, we want to do something different. We want to fall back. We want to have fallback languages so that, you know, even if we couldn't find the localization for language X, maybe there's a similar language where we can fall back to it, which is better than nothing, better than showing nothing. So having a fallback in case of errors. Also, the L10n registry allows us to do dynamic language changes, because the idea is, wouldn't it be nice if you realize that, you know, there's a different localization pack for Firefox. Currently what you have to do is you have to download a whole different version of Firefox if you want like the Hebrew locale, or if you want the Persian locale, if you want the Canadian English locale, you have to go and download that version of Firefox because it has the locale packaged into it. With Fluent, the idea is you'd be able to choose from a drop-down list what locale you want, and then Firefox can go and download that language pack, and you're good to go. So that's something that the new localization registry will allow us to do. And then the new localization API has been designed over last few years in response to the lack of good solutions for web localization. The existing technologies from Google, Unicode Consortium, and independent frameworks don't fit into our project's needs. Core of this technology is Project Fluent, a new paradigm of localization designed by the Mozilla L10n tech team. Fluent provides the low-level API, the new localization syntax. So those are the two big components, the L10n registry and the localization API. So let's take a look at the diagram here. So if we'll have like these various documents, things that are rendered in Vue or React or just some JS that wants a string or some Zool or HTML, then all of these things, like I guess if you want the JavaScript, the strings in script, then you have to like reach into the Fluent API, whereas if you're using a markup language, there's something called Fluent DOM. And then for React, Fluent React, and Fluent View, and then it goes through something called a message context, an L10n registry, locale service, and then we can get like the app Fluent files, and then the language pack Fluent files, and then we're able to like choose the right one. Okay, that's interesting. Let's take a look at the code for the L10n registry and see how that works. We have to start somewhere. So let's start with the L10n registry. It's written in JavaScript. And there's an L10n registry service. All right, let's see how this thing works. L10n registry. SmurfD asks, that would mean you only need one release rather than a gazillion per version, right? That is right. One release. You don't have to do all of the different releases. We'd still need to QA all of the different locales, but we wouldn't have to package and build one for every locale. And Akris asks, why is locale a problem? Couldn't you translate encoding to UTF first and parse everything as UTF? Yeah, I don't know if encoding is a problem at all, actually. Like, why is the locale possibly a problem with encoding? Probably not. I think everything's probably going to be UTF. I think my main concern is that with, I believe, UTF-8, oh man, I got to remember the stuff, how encodings work. You can express a character using only 1 byte sometimes, but the further you go up the character mapping, the more bytes you need in order to express that strings or that character. So there are certain locales that might use the upper characters, and so that means more bytes to represent them in memory, because that's how they're encoded, and therefore maybe more memory usage. I think that's what I meant before. Hopefully that answers the question. Okay, the L10n registry. Where does this thing, before we even like dive in to see what this thing does, let's see where it gets like bootstrapped from. Like, does it register itself as like an XPCOM component? Let's find out. XPCOM utils. It uses XPCOM utils, but really only does that in order to fetch things. Okay. L10n registry. Who imports it? Something called localization.jsm imports it. Fluent.js.patch. Extension.jsm. May process singleton. Huh. L10n registry needs to be initialized before any content process is loaded to populate the registered file source categories. So, okay, for any content. So, at this point, before our first content process is created, we should have the browser UI around. So, L10n registry, is it only used for content? That doesn't make any sense. You'd think it'd be used for other things as well. When is L10n registry used? Let's look at localization.jsm. So when is localization.jsm brought in? Aha! In localization.cpp and in something called mozintl.jsm. Okay, so let's start. I'm going to start taking some notes. What am I going to call this thing? Fluent performance sort of exploration. Let's see how Fluent works in the startup path. Arbitrarily, here, let me zoom in a little. Arbitrarily, I've chosen the L10n registry .jsm file as my starting point. When does this get loaded during the startup window? Okay. I mean, the other thing we could do, actually, now that I think about it, I have a better idea. Let's kill this build, because I don't think it's going to be done before the episode's finished. But I'm going to switch to an artifact build. And now I'm going to build my artifact build. And then what I'll do is I will get it to like dump a stack whenever L10n Registry is imported. And then we can take a look at that stack. That might be helpful. In the meantime, we'll just do a little bit of guessing. So localization, L10n Registry is imported by localization.jsm. And that's brought in by moz intl.jsm and inside localization.cpp. Let's take a look at this localization.cpp stuff. This is so interesting. It'll like import a JSM but from JavaScript. Or sorry, like a JavaScript JSM but from C++. When we init localization, we get the module and we call get localization on it. That's fascinating. So does localization.jsm somehow expose some kind of, like, how does C++ know how to talk to it? What is this get localization thing? Get localization. Because it's an exported symbol, maybe. Interesting. So you can call like exported symbols and get localization. Resource IDs synced is false. And then the out param is the return value. And what you're getting back is this like localization object or class instance. Yeah, so localization class is a central high-level API for vanilla JavaScript use of Fluent. Vanilla JavaScript. So not necessarily like the browser UI, but maybe for just normal websites. Because I'm pretty sure like there's a L10n API. Nope, that is not right. This is all like B2G stuff. This is not what I'm interested in. Localization API. No. Ah, interesting. Locale. Localization. What is this thing? Intel L10n. I think I've seen this being used before, like window.intel. Yeah, intel.l10n. No. So intel is this object. We can get locales. Window.l10n local. Nope. All right. Well, maybe it's not really exposed to the web just yet. Or maybe that's something that one could read about more if they were to read this document on how to use it on your websites. But for now, let's ignore that. Let's just keep focusing on the browser UI as our consumer. So get localization. We register observers. I'm not even sure if this is like our main entry point for the browser UI. I'm really guessing. So let's take a look here at our build, artifact build. So what I'll do is I'll say L10n Registry right at the top. I'm going to say dump L10n Registry imported, and then dump a stack. Okay, let's take a look. So it was imported by localization.jsm, and then there's nothing else in the, there's like, oh, and it was imported again, but I'm guessing that's because of the content process. So it happens twice. So that's interesting. That's a note. Things I've found out. Localization, L10n Registry is imported by localization.jsm once per process, parent, content, etc. Let's see. It looks like localization.jsm is imported by native code. So I suspect, like, if it wasn't native code, if it was JavaScript, I'd see it, you know, I'd see the rest of the frames in the stack, but I don't. So I'm inclined to believe that what we're getting at is, like, if it was Moz intl that was causing us to import, we'd see the Moz intl script, but we don't. So I'm forced to believe that it's this localization init stuff. So who calls localization init? Aha. So in a couple of different places, we've got things like DOM localization, document localization, and localization. What's the difference between these? So if we're constructing DOM localization, what is DOM localization? DOM localization. Oh, that's actually just like a top level, like a global. DOM localization. Is there like a document localization? There's not. What is this thing? DOM localization. Is there a web IDL binding? DOM localization, there is. Okay. It's an extension of the Fluent Localization API. DOM localization adds a state for storing roots, DOM elements which translation status is controlled by the DOM localization instance and monitored for mutations. So you connect a root, disconnect a root, you pause observing of roots, resume observing of roots. The idea being, I guess, that, you know, you could add one of those L10n IDs to a node, and we want to observe that and then update, like, dynamically insert the translation string, I guess. Interesting. I'm tempted to build with default. I'm tempted to continue the build here because it'd be nice if I had some assurance of where in the native stack, not just where, like, I know that it's localization.jsm is being imported, or where was it? Oh man, I lost it already. It's being imported by, was it DOM localization? Localization.jsm? No, something else. It was, yeah, the localization.cpp. And I'm curious to know which of the various pathways are causing that to occur. Because we've got like 2 different pathways here and one here. Are we constructing DOM localization or just normal localization? It seems like DOM localization wraps localization. And I guess that makes sense because localization is, well, what is it? Let's take a look at the header and get a sense of what it does. So DOM localization is a thing that can observe stuff and it can support a weak reference. You can construct it and then there's also a web IDL for it as well. Let's take a look. Web IDL, by the way, is the binding language that we use to expose things to the web, but also for privileged code. So here's localization.webidl. So L10n key is an object used to carry localization tuple for message translation. You have the ID and any args that. So I guess if you're making a request to translate a thing, you might pass in this as your L10n key to get back a translation string. L10n message is a compound translation unit from Fluent that encodes the value and optionally a list of attributes used to translate a given widget. Okay, L10n message. And here is a callback function which takes a list of localized resources and produces an iterator over Fluent bundle options used for localization with fallbacks. Okay. You construct a localization object with a list of localization resource URIs which provide messages for this instance, and a callback function will be used to generate an iterator. Callback will be used to generate an iterator over Fluent bundle instances. Don't really know what that is. Adding resources. You can remove resources from the context. You can ask it to format a value. This one's asynchronous. You can so here's an example. You can say document.l10n. Oh, it's on document. Document.l10n. That's the API. Document.l10n. Oh, not in the web, but in privileged code. Let's see, privileged JavaScript, document.l10, and yes, there it is. You can say format a value, and you pass in the key, and then you pass in some args, and then eventually it gives you back the value. Okay, that's fair. And then you can format values as a group. Okay. Format messages. What's the difference there? You format messages. Value. I guess what you get back is a value and attributes. Okay. Oh, I see. So in this case, the format messages is used to figure out how one would potentially decorate the DOM. So for example, you'd say, I have an ID of unread emails and an args of count 5. The value of the translation is you have 5 unread emails. It also tells you that the tooltip attribute of whatever we are should say click to select them all. Interesting. Help predict. So this is I think localization is the localization.webidl looks like the main Fluent API, at least from JavaScript's point of view. And then DOM localization. What was that one again? You could connect a route. So DOM localization is a little more passive, where I think you connect it to a node and it will automatically do the updating of the string values and attributes using those messages from localization.webidl. You can also say set attributes, set localization specific attributes on element. Okay. In this case, key 1, L10n args, email count. Okay. Set attributes, get attributes, triggers translation of a subtree rooted at a node, so you can translate a fragment of a tree. You can translate a list of elements. And then you can also choose to translate all roots. Okay. That makes sense, I think. So DOM localization, and that's probably the one that we have to worry about. DOM localization looks to like the thing that gets attached to a document, notices it mutating, and then automatically injects or updates translations in that document. Okay. Okay, so let's see if DOM localization gets constructed somewhere in our native layer. Because like we construct the browser UI from the XHTML markup, which contains both some HTML but as well Zool nodes. And as we parse those, I believe we must also initialize the DOM localization stuff, right? Let's find out. New DOM localization. Does anyone construct that manually? In CFR page actions, bookmark panel hub, and here in DOM localization. Whenever we are constructed. What? Oh, I guess. Constructor for DOM localization. Oh, this is, oh, I see. Is this a static? DOM localization constructor, which it's like a factory. It returns DOM localizations. Okay. So who calls that? Yeah, what's the definition? Static. It is a static. Okay. Okay. Factory. Makes sense. So who makes these things? Or like who causes these to get constructed? So here's one, CFR, here's another one, bookmark panel, document L10n, L10n mutations. What's the difference between DOM localization and document L10n? Did I already talk about that at all? No. Let's look at the header. Document L10n. This main class maintains the localization status of the document. The document will initialize it lazily when a link with a localization resource is added to the document. Oh! This might actually be the entry point. Document L10n might be the entry point for localization for the browser UI. I have another question. Hang on, questions. Are we planning on translating any strings that the user might see before any browser UI is presented? The only thing that comes to mind is the -- help stuff that we might see at the command line. Okay. Document L10n. So who constructs the document L10n? It says that like the document will initialize it lazily when a link with a localization resource is added to the document. Now that sounds familiar because .ftl. These things, I think this is how we kick it off, is you add an FTL link to the document, and that connects everything up so that it's kind of like this drop-in, like automatic behavior. So let's double check. Aha. Document L10n. Okay, so document.cpp creates it here in initialize localization. La-da-da-da-da-da-da. Let's play some sounds while we're waiting for SearchFox to get its act together. Okay. We want line 3724. Guess we're not quite there yet. There we go, 3724. In initialize localization, we construct this class lazily. Aha! Localization link added or on L10n resource container parsed. Let's take a look at these. Localization link added. SDK in IRC wonders if a local repeater would save you some trouble. Maybe, except that like I had a repeater that I was running locally and it wasn't that much better. I didn't really like maintaining it. I had this like Nginx thing that I was using. I prefer it if it, like whenever the Air Mozilla repeater works, it works brilliantly. It's just been these last couple times where, and I think this one was my fault because I updated, like I think I invalidated my Twitch stream keys and then I updated them at the wrong time and that caused the stream to fall over. I think it was my fault. So, okay, localization link added and there's a link element. Okay. And so we wait. If the ready state of the document is ready state interactive, then we're lazily initializing localization. Otherwise, we're still parsing the document. In that case, add it to the pending list. This list will be resolved once the end of L10n resource container is reached. And it looks like we block layout. Don't fire the load event until after that stops happening. Layout has a chance to start. Okay. Things I've found out. The HTML link elements that link to FTL files are what are our main entry point in browser.xhtml. When we see those, the document and localization link added, who calls that? No. No. Everything's really sluggish because of this build. All my CPU. Yeah, who calls that? What was this other thing I was looking at? On L10n resource container parsed. This message will be called once the end of the L10n resource container has been parsed. In Zool, this is the end of the first link set. Aha. Aha. So here we'll cause, because we have this like link set here. So I'm wrong. Bind to tree. Let's go to line 3759 and we'll go back and forth. 3759. It's a little confusing. No, it was the same document. I just wanted you to go up here. Oh, damn it. I didn't want you to reload it. Why are you reloading? Is this build maybe just making things too painful? Yes. I think it's making things too painful. Cancel the build. Cancel the build, reclaim some CPU. Let's look at this line instead. 3759, go. Okay. So here's one place we do it. If the document is already parsed, then we'd initialize here. However, so I'm wrong. So by the time we reach these, the document is not yet parsed. We're still waiting to finish parsing because we're still up like in the first, I don't know, first tenth of the document. But as soon as we exit the link set, then we say that the resource container has been parsed. This method should be called once the end of the L10n resource container has been parsed. Let's just double check. Who calls that? Trigger initial document translation. Done walking, handle end element, did build model. Handle end element. No idea. What about here? Did build model. Tree construction has ended and may be done walking. If we have pending initial translations, then we trigger initial document translation. Here. Okay. Well, according to the documentation, we say that we call this whenever the L10n container has been parsed, or if done adding children. If we're done the head, then we say that we're done parsing it and we're done adding children here, and it was a link set. Okay, I see. So we're done adding children to a link set. Then we call, okay, I see. The HTML, the link set contains HTML link elements that link to FTL files. This is our main entry point. This is our main entry point, it seems. See those, the document calls when we see the end of the first link set, the document calls on L10n resource container parsed, which causes document L10n to be constructed, right? Because we call initialize localization. Also, for the folks who might be watching this on Twitch and are trying to talk to me in the Twitch stream, in the Twitch chat, I have I closed the Twitch chat, so I haven't been reading it. So, sorry if you've been wondering why I'm not responding to anything. But I am still in IRC. My whole Twitch rig, the whole I changed my password for Twitch, and that basically caused the whole repeater foul up at the last moment. And I think that's also locked me out of the IRC gateway that I normally use to talk in the Twitch chat. And what I was doing before was I was using my Twitch page to talk to you all using the normal web interface for the chat, but it was consuming too many resources during my build, so I closed it. Long story short, I'm not in the Twitch chat anymore. I'll hopefully have all of this sorted out next week. Okay, so we initialize localization. We construct this document L10n thing. And then we have it available so that if anyone ever calls get L10n, we have it there. And this thing, I think its job is to actually do the work of, I see, figuring out whether or not the document We get the current content sync. We get the document element. We figure out whether or not the L10n sync attribute is set. That's interesting. Does anyone actually use that? Data L10n sync. Aha. We do. So in the main window, we say we're going to do some sync translation. I wonder why that was added. Allow document L10n to use that, and let's see, latest version without this line. It looks like we did that as part of the menu bar stuff. Sync. The reason it failed is because hidden window mag was loading before browser XHTML and triggered async loading of 3 FTL files, and then browser XHTML tried to load the same files but sync. What? L10n sync. He added it here, right? Data L10n sync. Yeah, he does. The main windows. He makes them both sync. In browser.xhtml and hidden window mac.xhtml, L10 localization occurs synchronously. We initialize ourselves. We create a promise that says whether or not we're ready. This trigger initial document translation, we saw this earlier. That occurs, I think, when we're done. When we're done. Yeah, we're done building the tree. When the document has finished being parsed, we trigger initial document translation. So this is before the layout step. We see whether or not we're already beyond initial translation triggered. If so, we bail out. Otherwise, we enter that state. So, okay, we're a state machine. Get the document element. If there's no element, if there's no document element, then we reject, okay? Otherwise, we collect all localizable elements. So we get translatables. Get translatables. How does that work? Getting a translatable means walking all of the nodes, it looks like, and seeing if they have data L10n ID. Okay. So, suspected Fluent flow during startup. Browser.xhtml is parsed. The last link, the first link set ends has its last child parsed. So all this stuff happens. L10n is created synchronously. The document finishes being loaded. Initial document translation is started. for browser.xhtml hidden window mac.xhtml, this translation is going to be synchronous. All right, I'm starting to understand. I'm starting to understand the flow of things. This feels good. I like to understand. Okay. Was it document L10n walks the DOM tree, finding any nodes that have data.l10n ID attributes and collects them as translatable elements. Or just translatables. Translatables. Then we get the prototype of the document. If the document is a prototype that may cache translated elements, handle the case where we have a proto, move elements that are not in the proto to a separate array. Okay, so we see if there is a document prototype, and if there is one, then we go through all of the translatable elements. Has element created from prototype and has unmodified L10n. Wow, what? We get bool flag element created from prototype and has unmodified L10n. These are Boolean flags. Set if the element was created from prototype cache and its L10n attributes haven't been changed. Okay, I see. If so, we have started to create another list. We're like separating out the elements into the ones that exist inside the prototype cache and the ones that don't, the non-proto elements. We populate the sequence reverse order. Let's bring it back to top, bottom one. Okay, if we're not loading from cache, push the elements that are in the prototype to be translated. If the prototype wasn't L10n cached and the elements is not empty, so elements that were created from the prototype, we're going to translate the elements. Pass in the prototype. Okay. Translate elements. The attributes. Create a promise that, okay, if we're synchronous, then we're going to go through here and we're going to apply the translation synchronously and then resolve the promise. Otherwise, we do it asynchronously with format messages. Okay. When does it go into the prototype cache? If no translate promise, or if it failed somehow, then we bail out. Otherwise, we add it to our list of promises here. And if the things that weren't prototype elements is not empty, localize them without attempting to cache independently of if we're loading from cache. Wait, what did we do with the prototype here? A proto. Element translation handler. I think this is what's going to be doing the caching, because that's what we passed. Promise handler used to apply the result call localization format message onto the list of translatable elements. Is there like a, so it takes the prototype, mproto, DOM localization apply translations. Prototype. If proto otherwise means rebuild the L10n prototype. Build prototype from element. And somehow the prototype is stashed and serialized. Yeah, here. And that's how it works. Like that's why we do all this prototype stuff, is like we store after the first load. Okay, this is interesting. During startup, if this is the first load, we don't have any translated strings inside of the prototype cache. We presumably don't have any translated strings inside of the prototype cache and translate them synchronously. If this is not the first load, then after the document is parsed, we try to get at any strings that we try to load after translate them synchronously, elements that can be part of the prototype cache. And I don't know again how you differentiate. Prototype cache for the document are then serialized for the startup cache. After the document is parsed, elements that were translated elements that were part of the startup cache are ignored. Will unmodified translated elements are part of startup cache are ignored. They're already translated. Okay. Other elements are still translated synchronously. Let's go back. We gotta go back, Marty. Was L10n cache? So what is, has element created prototype? If we're not loaded from cache, push the elements that are in the prototype to be translated and cached. Proto was L10n cached. Translate. Okay. And there's some elements that were not created from the prototype. I guess there's some elements that, yeah, aren't stored in the prototype for some reason. I don't know why that is. If there are elements that are not in the prototype, localize them without attempting to cache independently of if we're loading from cache. Okay. And we just like translate those synchronously. Collect promises with promise all. Translate all elements without attempting to cache them. And then we fail if we fail. Connect the root to, okay, now we attach the L10n mutations observer so that if any of the document changes over time, we can still translate that stuff. If the promise is already resolved because we did this synchronously, then resolve immediately, otherwise schedule the L10n ready handler. Okay. And say initial document translation completed. Is sync We want to change the state of Moz I localization to async now, so the future localization occurs asynchronously. Okay. Okay. So here's what. Okay, other elements are still translated synchronously. After the translation occurs, the document goes out of synchronous translation mode, synchronous translation mode, and further updates to the DOM monitored via a mutation observer will happen asynchronously. Okay. SmurfD is asking me if I understand it fluently. Booyah! That's very good. Oh, yeah. I like it. I like it, SmurfD. Let's see. What else is there to know here? So what I want to know, I want to measure, things to measure on reference hardware. How much does it cost to do the initial translation without the startup cache? How much does it cost to do the translation with the startup cache? Okay. So, like, how, yeah, what proportion, since this block's layout, how often, how long does Fluent block layout, and therefore painting, presenting? What is the relationship between the number of translated elements and the amount of time that we're blocking layout? Does that relationship is that relationship different when loading from the startup cache and not? Okay. What else do I want to know? How well did the DTD translation stuff work before? How fast is it? Okay. What kind of disk activity does Fluent cause? We're loading not only the current locale, but it sounds like we load backup locales. Okay. So those are things I would want to measure. All right, I think I'm going to stop here, but I think I have a much better sense of how localization and Fluent attaches to the first browser window. I think some of that I had, like, I'd seen it in presentations, and some of it kind of bubbled to the surface from my subconscious. But it's nice to see how this all kind of works in the code to verify those assumptions. And let's see, I don't see any chatter in live hacking. Let me just quickly see if there's any chatter inside the Twitch chat. See if there are any questions there. A question from MCIer. Maybe, why is JSM imported twice in native code? Good question. Good question. Why is the JSM loaded twice in native code? I suspect it's once per process. So in our test case, that was once for the parent process and once for the content process that loaded about home. So questions, are there things, can translations be shared between processes? Like that seems like it would be a bunch of things that could go into shared memory. Certainly this would help reduce memory overhead amongst content processes for the places where we have strings in content processes. I don't see any chatter inside of the Twitch chat. I did load it up. Hello, Twitch people. Give you a little wave there. So I think I'm gonna cap the stream. I'm gonna end it here. Thank you so much for thank you so much for watching episode 100. I can't words today. Whew. All right, hang on. Deep breath. Thank you so much for watching episode 189 of The Joy of Coding. I hope that was interesting. Did a little bit of stuff with Fluent, worked through the code, try and understand how it works. I'm feeling more confident about what I want to measure, how I want to compare it against DTD and properties, and the trade-offs, so we can evaluate it during the startup window. Memory usage, we haven't really scratched the surface yet, but in terms of getting a snapshot of how it works during the startup window, I think it's starting to take shape. So thumbs up there. With that, I think I'm going to cap the episode. Yeah, thanks so much. I will catch you next week with episode 190, and then we're only 10 episodes away from episode 200. Let's do some quick math here. 2019 calendar. Let's take a quick look at a calendar here. Okay, so it is the 18th. So let's assume that I don't have any more breaks coming up. Let's just assume that. So then next week is episode 190. And then after that, episode 191, 192, 193, 194, 195, 196, 197, 198, 199, 200. So with a little bit of breathing room in there for holidays, breaks, being sick, it's possible that episode 200 will either be in December or early January. So I've only got 10 episodes until that occurs. Let me know what I should do for episode 200. Fill in the form. There is a form here to rate the episode. Give me some ideas on things I can do. One of you, SDK, Danny Colin, gave me this great idea. I've had this reviewer periodically named Jason Voorhees, and I should have like the from Friday the 13th be part of like my soundboard. Every time he's reviewing me. I love that idea. Keep those ideas coming. Maybe there's other stuff that I can do to improve the stream for you, or do something special for the 200th episode. Maybe you want me to do like a deep dive on a particular feature, or you want me to, I don't know. Let me know. Maybe you want me to work on something that's not about Firefox. Maybe I'll work on a web extension or something completely non-Mozilla related. Maybe I'll explore a piece of someone else's code. Maybe I'm a fan of Scum VM. Maybe we can do a deep dive on how Scum VM works. Who knows? Let me know. Fill out the form and let me know what you think. It's in the agenda here. And with that, I'm going to end the episode. Thanks again for watching The Joy of Coding. Take care. Bye-bye. Hold on, guys. Do this tradition. Yep. See ya.